So what is a pipe basically? Pipe क्या है? Pipe is a closed passage for the flow of fluids. Pipe is a closed passage for the flow of fluids. So here, to run the chilled water or to run the hot water or to run the refrigerant, we use pipe. Okay, piping system. So coming to piping system, we have two types of piping system. Once through piping system, and next one is recirculating piping system. Once through piping system and recirculating piping system. So once through piping system means, in this system the medium flows only once through the pipe. So pipe से एक ही बार मीडियम का ट्रैवल होता है. एग्जाम्पल, वाटर फ्रॉम ओवरहेड टैंक टू टैप. ओवरहेड टैंक से टैप तक पानी चलता है ना, उसको वंस थ्रू पाइपिंग सिस्टम बोलते हैं. नेक्स्ट वन इज रिसर्कुलेटिंग पाइपिंग सिस्टम. सो रिसर्कुलेटिंग the medium in this system, the piping system is, in this system the medium circulates in a closed loop. The medium circulates in a closed loop. Okay, it always been circulating in a closed loop. Example, refrigeration cycle. Got it? Refrigeration cycle is the best example for recirculating piping system. Now, yes, any question? Okay. So in the recirculating piping system, again it is classified into two types. Closed piping system and open piping system. Closed piping system and open piping system. So coming to closed piping system. Okay, coming to closed piping system, the medium circulates in a closed loop. The medium circulates in a closed loop and the medium exposes to atmosphere at a point as there may be breakage, as there will be breakage in between the pipes. Breakage in between the pipes. पाइप्स का बीच में ब्रेकेज होता है, ये क्लोज लूप में ही चलता रहता है, बट द मीडियम एक्सपोजेस एट ए atmosphere to a point. Example, water from, example, piping between chiller to cooling tower. Cooling tower पे breakage है ना pipes के बीच में, and then water is exposing to atmosphere to cool down. So this type of piping system is called as open piping system. Closed piping system. In this piping system, the medium circulates in a closed loop and medium nowhere exposes to atmosphere at a point. ये किधर भी atmosphere को expose नहीं होता. It is completely closed. Okay. Example, piping between chiller to एच चिलर का बीच में किधर भी एक्सपोज नहीं होता है, वो पाइप के अंदर ही चलता रहता है. दिस इज कॉल्ड एज क्लोज्ड पाइपिंग सिस्टम. ओके, नेक्स्ट, एनी डाउट स्टिल हियर?
नो सर.
एनी डाउट्स यू हैव? ओके, सो डक्ट साइजिंग करने के लिए आपको क्या क्या पैरामीटर्स ले रहे हैं? डक्ट साइजिंग के लिए पैरामीटर्स क्या क्या ले रहे हैं आप? क्या क्या चाहिए डक्ट साइज करने के लिए?
CFM.
CFM. वो क्या है CFM?
Velocity.
CFM is volume, right?
Yes.
Yes, very good.
Height.
For pipe sizing also, पाइप साइजिंग के लिए भी हमको वॉल्यूम चाहिए और वेलोसिटी चाहिए.
Velocity.
So here volume we take in terms of GPM and velocity we take in terms of FPS, feet per second, GPM gallons per minute. So for open piping system, GPM equals to TR into open, right? 3.0. Standard formula, sir. This is TR into 3.0. For closed piping system, GPM equals to TR into 2.4. Okay, FPS. Velocity. FPS means feet per second. This is suction side of the pump. This is pump. And this is discharge side. So in the suction side of the pump, velocity will be 4 to 7 FPS. So approximately we go with 6 FPS. In discharge side, we go with 8 to 12 FPS. Approximately, we go with 10 FPS. Guys, am I audible now?
Yes, sir.
There are some issue with my mic always. Where we are? Okay. Next, can someone
Yes.
share me that?
Screen is not visible, sir.
No screen. I just
Okay. Yes.
restarted my system. So I'll share 1 minute. Okay. So let's go with sizing. Okay. So now the heat rejection equipment of 500 TR requires cooling. Find out pipe size and friction loss in the discharge side of the pump. So first, what type of piping it is? First, what type of piping it is? Open or closed?
Closed.
How it is closed? Can you explain? Tell me.
Because the machine is rejecting heat to outside to surrounding.
So what is heat rejection equipment basically?
Decrease the inside temperature.
What is that? Condenser or evaporator?
Condenser.
Condenser. Condenser is connected to cooling tower, right?
Yes, sir.
And then it is open or closed?
Open system.
Open system. It's open system, right? What is then GPM? As it is open system, what is GPM we have now?
TR into 3.0.
TR into 3.0. So as it is TR into 6, and how much?
1500
1500 is the GPM.
GPM.
Yeah, 1500 GPM we have. So as 1500 GPM, what they are asking, friction pipe size, friction loss in the discharge side of the pump. right? Now let me share one more screen with you. If you see here, this is closed piping system. This is open piping system. Now we are talking about open piping system, right? We are talking about open piping system.
Yes,
So
sir.
as it is open piping system, okay, as it is open piping system, now 1500 flow easy here. This is 1500, right? Okay, 1500 is this. Now velocity, how much we have? Discharge side velocity is 10, right? This is velocity. See here, velocity here. Okay, so velocity 10. So this 10 is cutting here. So now this is the value. So as this is the value, this is lying in between 8 inch, near to 8 inch, 8 inch pipe size. This is. So we'll take a pipe size of 8 inch. Okay. Next friction. So this is going near to 5 like this. See, that point is going near to 5. This point. This is friction value. Here also you can see. Here also you can see in the down also. See, friction loss in the feet of water gas per 100 feet. Okay. So pipe size is 8 inch and friction loss is 5 feet of water gas per 100 feet. This is how we find the values. Just allow me 1 minute. Okay. So let's work on finding pump head. So is it clear how we find the pipe sizing, everyone? Yeah, good. Now tell me what type of piping it is.
Closed one.
Closed. Very good. Okay. So now we need to find out the pipe size, pipe for primary pump and secondary pump. Okay. So primary pump which supplies chilled water, sorry, which supplies chilled water return to chiller, and secondary pump is which supplies chilled water to AHU. Okay. Now E indicates elbow, 90 degrees, long radius. Capital G indicates gate valve. Gate valve is like a isolating valve. So it will start the flow or stop the flow. Globe valve is for controlling the flow. S equals to strainer. Strainer is used to filter the water. Okay. Y type strainers we have. Next, N, non-return valve or swing check valve. Non-return valve or swing check valve. Okay. So these are the different types of valves we have. Non-return valve means when you are lifting the water to the top, ground floor से 10th floor को lift कर रहा है. So when there is a sudden power cut, तब क्या होता है सर, पूरा पानी वापस आता है ना, उसका प्रेशर इम्पैक्ट किसके ऊपर होता है? Where the pressure impact will be? On the propellers of the pump, right? Am I right or wrong?
Yes, sir.
So to protect the pump, we have a non-return valve. That means it allows the flow only in one direction. एक ही डायरेक्शन में फ्लो को वो अलाउ करता है. ठीक है. Now identify the pipe size from A to C and C to F. Pipe size and friction loss identify करो.
So from A to B, that 30 is in inches or in feet?
That is length. I'm asking. That is length. I'm asking size, diameter.
What will be the velocity, sir?
Find out velocity.
Then which one is the second value? We only have the GPM value.
GPM value. What is this? This is what? Pump, right?
Yes sir.
पंप का सक्शन ये है ना,
Okay.
ये पंप का
6
डिस्चार्ज है.
SPM. Okay.
Done.
Size is 9 inches, sir.
5-inch friction loss.
9 inch, sir. 9 inch size.
9-inch friction loss.
10.
As per market availability, 9 ही नहीं है ना. It is in between 8 and 10, right?
Yes, sir. Then
You
8
need to go with 10-inch then.
10 and 1 friction loss is 1, not 10.
1200 you will get. 1200 or 6.
Yes.
1200 and 6. So friction loss is 1.5.
1. It's near to 1, na, sir?
No. It will be around 1 or 1.5 का बीच में आता है basically. So you can go with 1.25.
Okay, sir.
Okay. Let me share you one table now. So have you everyone drawn this one? ये draw किया है ना? Draw that one fast. Draw it.
Done, sir.
యా దోమలు కుడుతున్నాయి ఓ పక్కన సౌండ్ వస్తుంది ఫ్యాన్. ఓకే, లెట్స్ స్టార్ట్ విత్ సీరియల్ నెంబర్ 1. ఐఎమ్ టేకింగ్ ఫ్రమ్ section A to C directly, sir, as the pipe size is same. AC. So what is the item name? Straight pipe. So basically I'll explain you here. So to do the pump calculation, so we need to have total dynamic head loss. Total dynamic head loss calculations. This is head loss. So total dynamic head loss equals to total suctional head loss plus total discharge head loss. This is the basically total dynamic head loss equals to total suctional head loss plus total discharge head loss. So while calculating total dynamic head loss, first we are calculating total suctional head loss. Total suctional head loss. So as it is a straight pipe, GPM, what is the GPM value? We are taking GPM as 1200, right? We are taking GPM as 1200, right? FPS, how much we have taken? We have taken it as 6. So pipe size, what is the pipe size you got?
10 inches.
10 inch.
Yes. 1.25.
Length of straight pipe, it is 30 plus 15, 45. Equivalent length 0. So that equivalent length, I'll tell you what it is. That equals to F into L. This is F into L, total length, divided by 100. So look at this value. Next, serial number 2, section AC पे ही काम कर रहा हूं मैं. I'm working on AC. Next we have gate wall. So I'll go with same values, 1200. GPM will be 1200. Same flow will be there. FPS will be 6. Pipe size will be 10 and 1.25. And straight pipe का length 0 होता है. Equivalent length आता है sir. Here you will get as a equivalent length. So see here, you can see here equivalent length value losses in equivalent feet of the pipe. Valve losses in equivalent feet of the pipe. This is gate. Okay. 10 इंच 10 इंच के लिए गेट वॉल्व कितना है? 12. Okay. You choose, you put that one with you, the table. It is from page number 26. So 12 total, that equals to this plus this basically, and same formula applies here. नेक्स्ट AC में गेट वॉल्व के बाद क्या है? ग्लोब वॉल्व है. सेम 1200 6 10 1.25 0. ग्लोब वॉल्व का वैल्यू कितना है बताओ एक बार? 280. वेरी गुड. 280 फीट है वो. सो विल गेट द वैल्यू 280. गलत आ रहा है. हाँ ओके. नेक्स्ट AC. ग्लोब के बाद क्या है? एल्बो है. ट्वेल्व 6 10 1.25. ये ग्लोब आप एल्बो का वैल्यू आपको मिलेगा इधर सर. आपके एल्बो का वैल्यू मिलेगा नेक्स्ट पेज पे, पेज नंबर 28 पे. लॉन्ग रेडियस एल्बो देखो 25. 10 इंच के लिए हमें 25 है. सॉरी नॉट 25, 16 है. लॉन्ग रेडियस एल्बो वी हैव
16.
यस.
Yes, sir.
एल्बो के बाद अगेन गेट है. Elbow के बाद again we have gate. See how I am working, like that only you need to work. Gate, again gate wall. Gate means 12 again. Next gate के बाद strainer. Strainer का वैल्यू बताओ. 190. सो दिस इज सक्शन का हो गया. ठीक है, सक्शन का तो हो गया. आफ्टर
नॉन रिटर्न वॉल का
सक्शन
कुछ नॉन रिटर्न वॉल का नहीं आता है क्या सर?
नहीं, मैं क्या कर रहा हूं, सक्शन साइड, ये पंप का ये सक्शन साइड है,
यस सर.
ये डिस्चार्ज साइड है. राइट.
ओके ओके.
सो मैं सक्शन हेड लॉस तो कैलकुलेट किया. नेक्स्ट we'll calculate discharge side. Total discharge head loss. Discharge head loss. Serial number 1. Section D to F. Item name straight pipe again. ZPM 1200. FPS 10. Pipe size 8 inch. Friction friction 4, right? Dheeraj, friction.
Yes sir. 4.
It's 4. 20 plus 25. ये 20 feet है, ये 25 feet है. 20 plus 25 45. 0. That equals to this plus this. That equals to I'll directly copy the formula. Control C, Control V. See, when you need to know Excel also very good in this. Okay. नेक्स्ट D2F में क्या है? स्ट्राइट पे के बाद NRV नॉन रिटर्न वॉल्व है. नॉन रिटर्न वॉल्व विल बी इन द नेम ऑफ स्विंग चेक वॉल्व. 10 8 4 0. स्विंग चेक वॉल्व का कितना है बताओ? 100. लेट मी चेक वंस. स्विंग चेक वॉल्व,
sorry 80.
swing check wall for 8 inch, it is 80. DF NRV के बाद गेट 1200 10 8 4 0. गेट
Nine.
वॉल 8 inch 9. नेक्स्ट आफ्टर गेट वॉल के बाद क्या है? एल्बो है.
Elbow.
सॉरी DF एल्बो 1200 10 8 4 0. गेट एल्बो का कितना है?
13.
DF एल्बो के बाद अगेन गेट है. 1200 10 8 4 0 9. राइट.
Yes.
DF गेट के बाद स्ट्रेनर 1200 10 8. स्ट्रेनर का वैल्यू 150. So after summing these values, if you sum these values, you'll get TSH, total dynamic head loss, total suctional head loss. After summing these values, you'll get total discharge head loss. Therefore TDHL equals to TSH plus TDH. TSH plus TDH, that equals to this plus this, which is 63.9, approximately 64 feet. 64 feet. Okay, make a note of this fast. Note down these values, tables. Is it done, guys?
Yes, sir.
Yeah. Pump head equals to pump capacity equals to GPM into TD HL into specific gravity of secondary refrigerant divided by 3960 into efficiency of pump. That equals to 1200 into specific कितना आया TDHL? How much TDHL is?
64.
64 into specific gravity of water. We are using water, right? Secondary refrigerant. Water divided by 3960 into efficiency of motor 0.75. 75%, sir. So efficiency of motor आप ले सकते हैं 65 to 85. 65% to 85%. What is the value you will get here? So 1200 into
25.85.
64 divided by 3960 divided by 0.
25.85.
25.85. That is 25 HP. So this is how we find. Okay. So this is how we find the capacity of the pump. Clear?
Yes, sir.
Make a note. So tomorrow we'll be working on the ventilation concepts. And one fine day, I'll give time on one fine Sunday. If you complete load calculations, I'll give time on fine Sunday. We'll work on hourly analysis program. HAP.
So there are a lot of query in that design.
Yeah, tomorrow we'll discuss.
Yes,
Okay.
please, sir.
Tomorrow evening we'll sit and discuss in first half an hour. Later we'll start the class.
Yes, sir.
Okay. Thank you, everyone.